A very good evening to all of you. So today we'll try to understand the IC 555 timer. I have already given the assignment on IC 555. So I think you might be having a small idea about this, enough idea I can say about this IC 555. So basically this IC 555 is an 8-pin IC. It is a DIP package IC that is 4 pins on the left side and 4 pins on the right side. So as you can see that this is a unipolar IC. It means that there are no two supply, that is plus VCC and minus VE in the op-amp case. So here the 8th pin is VCC and the first pin is ground. So we'll be studying all the other pins in the meanwhile. The fourth pin is the reset pin. Reset pin means what? When you are going to apply the high pulse on this pin, then the entire IC will be reset. So we'll try to understand all the other pins by using the internal diagram of the IC 555. So you can see that this is the internal diagram. This is the internal circuitry which is there in the IC 555. So this is the circuit which is there in the IC 555. You can just have a look here. So okay, so what you can see that there are three 5 kilo ohm resistor. You can see 5 kilo ohm resistor and the second 5 kilo ohm resistor, and this will be third 5 kilo ohm resistor. So what we can see that this is the 5 kilo ohm, this one is 5 kilo ohm, and this one is 5 kilo ohm. Now to this voltage divider network, the power supply of plus VCC is connected. So what you can see that what will be the voltage at this point and what is the voltage at this point. Now this is the grounded. So you are having three 5 kilo ohm resistor. I can draw here. You can have three 5k ohm resistor, and these are between the plus VCC. You can have the 5 volt also, or means above 5 volt. Below 5 volt, this IC is not going to operate. This is plus VCC and this one is ground. So what is the value of voltage at this point and what is the value of voltage at this point? So VA will be equals to what? VA will be equals to, this is 5K upon the summation of all the resistance, that is of 15K into VCC. So that will be VCC upon 3. So the value is VCC upon 3, and if this is symmetrical, the all the resistors are having the same value, so VB will be equals to twice VCC by 3. So you can have a look here. This is twice VCC by 3 and this is VCC by 3. So this point will be given to the comparator. Now you can you can ask me a question that whether this is the op-amp or not. This is a simple comparator, and comparator will be having only two values, that is 0 or 1. So and it depends upon which input is higher. Suppose if the non-inverting input is higher than the inverting input, then you are going to get 1, otherwise you will get a 0 value. So there are only two distinct values, and this will be fed to the SR flip-flop. I think this will be covered in a digital electronics, but still for this IC 555, I'll be telling you that this is the SR flip-flop, and it is going to it will set and reset the output of the flip-flop. The flip-flop is a device which is going to store only one bit of information. Either it will store 1 or it will store 0. Now suppose now suppose if you are giving 1, fine, to what? S will be equals to 1. Suppose S will be equals to 1, then this is set. So this will give a command to the output to set the output, that is, so Q will be equals to 1. So when Q will be equals to 1, your transistor is going to operate. Fine. So this transistor will be operating in only two modes. The first one is the saturation mode, and the second one is the cutoff mode. So when the transistor will be operating in the saturation mode, this will be acting as a closed switch, and when it will be operating in the cutoff mode, it will act as the open circuit. Fine. So when one will be given, so this transistor will be short circuited, and then you can have some discharging path. You can discharge your capacitor if suppose if you add the external components which is a capacitor, so you can charge or discharge using this transistor. So we can say this is the discharge one. So the 7 pin which you can see in the pin diagram, that is seventh is a discharge pin. Fine. So now here fifth one is the control voltage. We'll be studying this also. So this is the 2 by 3 VCC, right? So 2 by 3 VCC will be given to the this input, and 1 by 3 VCC will be given to the first input of the comparator 2. So I think the one of the inputs are defined, and now it depends. Now the output of the comparator depends upon the second input which you are applying. So I think to this 6 and 2 will be connecting some external element, and that is none other than the capacitor. Fine. This is the internal structure of the what you can say the IC 555. Now the fourth pin is the reset pin. Now suppose if you put a high pulse, then this entire circuit will be reset. So that is when S will be equals to, this is about the flip-flop. When S will be equals to 1, R will be equal to 1. That Q is the output of the flip-flop. So Q1 will be equals to 1. These are the complementary output. These are the complementary outputs, and the output of the timer we are taking from the Q bar. So when Q will be equals to 1, Q bar will be equals to 0. Now the second one will be equal to when S will be equals to 0, R will be equals to 1, then Q will be equals to 0 and Q bar will be equals to 1. These are the complementary outputs. We don't have to do anything about it. So now, so I think we'll be using only two state. When S will be equals to 1, R will be equal to 0, and when S will be equal to 0, R will be equals to 1. So with this, we'll try to understand, or you can say study the different types of the multi vibrator, or you can say the IC 555. So there are three types, that is the Astable Multivibrator, which we generally use for the square wave pulse generation. Then second one is the monostable, only one state is stable. Astable means what? No state is stable. I think you'll get one for a certain time, then you'll get zero for the other time, then again one, again zero. So this is a repetitive. So by using this concept, you can have the square wave generation using the IC 555. Now the same is not the case with the monostable and for the bistable. In the monostable, you can have only one state which is stable, other state is unstable, and for the bistable, both the states are stable. So we'll try to understand each multivibrator one by one. So now you can see here, this is the internal structure. This is the internal structure which I am talking about, that is the IC 555. And why the name IC 555 given to the IC 555? Because we are having 5 kilo ohm resistors. So 3 5 kilo ohm means what? IC 555. That is the thing. So now to this internal circuitry, we are going to connect some, external elements. Like you can see here, RA, RB, and zero point 0.1 microfarad. So these are the only three elements which you will have to connect to the IC 555. And this will be connected either to the VCC because we want to charge a capacitor, and for charging a capacitor the power supply is required, and for discharging you need a ground path. So for ground path, this will be connected to the discharge transistor. This is a discharge transistor, we can say. Fine, this is a discharge transistor, we can say. So how to start with this? How to start? So initially, what is going to happen? Initial, that is the initial state which I am talking about. Initially, this is reset. Fine, this one is reset. So okay, I'll take the power supply as 5 volt. I am taking the power supply as 5 volt. So when 5 volt will be given, it means that what is the value? Or I can say 15 volt I am taking to make it more clear. Suppose if you are having a 15 volt power supply, the 5k resistor is there, then you will be having a 5k resistor, and this one is also a 5k resistor. So at this point you are going to get how much voltage? 5k upon 15k into 15. So 15, 15. So I think you will be having a 5 volt. And these are the fixed voltages, and this will be given to one of the inputs of the comparator. So basically, this one will be 5 volt. This is a 10 volt. This one is the 10 volt. This one is 10 volt. Fine. Now you can see the 6 pin and the second pin will be connected to the capacitor, and you can see the capacitor, it will be charging and discharging. So when it will be charging and discharging, the voltage across the capacitor is going to change. The voltage across the capacitor is going to change. It depends upon the power supply. It depends upon the discharge path. So you can say that this voltage will be a changing voltage, and this changing voltage will be applied to the the second inputs of the comparator. Fine. Okay, so initially there is no voltage across the capacitor. As you know that capacitor is initially uncharged. We have just bought this capacitor from the market, and we'll try to do some experiment on the I say 555. So basically this voltage will be equal to 0. So you can see that this one will be given to the sixth pin will be a 0 voltage, sixth pin will be a 0 voltage. So a 0 voltage will be here only, 0 volt and the 0 volt. I think it is properly visible. So 0 volt, 0 volt. So the capacitor is going to charge, and the capacitor will be building a voltage. So when the capacitor will be building a voltage, so it will start to increase from 0, then 1, then 2, then 3, then 4, and then 5. So I think it is, yeah, it is going to reach that one. So initially what is going to happen when this is I think what 0 means, 0 and 10. Initially for initial stage, this is 0 and 10. So 0 will be compared with 10. I think the first input is not higher as compared to second input, so you are going to have a 0 value. Now similarly, if 5 is higher than 0, so this one will be 1. So reset. Fine. So a reset path, so I think this is 1. So R will be equals to 1. It means that the output of the flip-flop will be equals to 0, because it is going to reset the flip-flop, and 0, it means that this will be in the off circuit. So there is no discharge path. I think initially there is no discharge path. Initially capacitor is going to charge only. So capacitor will be building a voltage. It is going to 1. So suppose this capacitor has crossed 5 volt, because we are having only two limits, no, that is 5 volt and 10 volt. Suppose if the capacitor has crossed the 5 volt, now it is 6 volt. Fine. So 6 volt will be here. Similarly, the same input is given here also. This is 6 volt. This is 6 volt. Now this is 6 volt. Now what is going to happen? You can see here, this is 6 volt. Again it will be a 0 only. Again it will be a 0. It will be a 0. So this 0 and 0 means no state. I think initial state, we can say initial state. So initial conditions will be applied. Your transistor will remain in the off condition only. Fine. 0 0 means what? Initial state. This we are going to learn in the fourth semester. So initial state means what? Initially the transistor was off and there was no discharge path for the transistor. So capacitor will starts to will starts to build the voltage again. So I think 6 volt, then 7 volt it will charge, then 8 volt, 9 volt, 10 volt. And then suppose if this crosses the next limit, that is 11 volt. So now you are having voltage, you are having the 11 volt. Fine, this one will be 11 volt. So now this 11 volt is higher than 10 volt. 11 volt is higher than 10 volt. 11 volt is higher than 10 volt. So what is going to happen? This one will be 11 volt is higher than 10 volt. So I think this one will be 1 and this is 0. 1 means what? You can see the discharge transistor will be on, because the base of the transistor will be at plus 5 volt. 1 means what? plus 5 in the analog language value. So 1 will be given to a transistor. So this will be acting as a short circuit because plus 5 is for, it means that the transistor is going to operate in the saturation region, and that will be acting as a closed circuit. Fine. So whatever a capacitor has developed a voltage that will get discharged through this path. So now you can see the path will be this only. So the path will be, you can see here the path. I'll just change the color. I think the color is required, very much required to understand the concept. Yeah, it is discharge. So this is the path. This one is the path which I am talking about because the S will be equals to 1, 1. So the capacitor is going to discharge a voltage. So when the capacitor is discharging the voltage, it means that the voltage across the capacitor will decrease. So now it will decrease from 11 volt, then it will come to the 10, then it will, suppose if it is 9 volt, suppose if it is 9 volt, if I am giving 9 because it has discharge, no, so this is 9 and this is also a 9. Fine. So 9, it means that 9 and 10, this is I think 0 0. Okay, 0 0. Okay, so again initial state, so it means again that path will be there, again the discharge path will be there. So again it is going to decrease, it is going to decrease. Now suppose if this crosses 5 and it will come down to the 4 volt. So now you are having 4 volt, 4 volt, this is 4 volt, this is 4 volt, this one is 4 volt. So what is going to happen, this will be 0 only and this one will become the 1, this one will become 1. So this is 1. Okay. In that case it will be a 0. So now when the 0 voltage will be there at the base of a transistor, so your transistor will be off condition, so this will act as the open circuit. So again your capacitor is going to charge, again your capacitor is going to charge, again the entire thing is going to repeat. So I think what you have obtained, you have right, just a minute, I'll just right. Okay, I'll draw the waveform of the capacitor voltage. Suppose if you have taken a 15 volt VCC, so what is going to happen initially? It will charge to right. So when the 10 volt, when the capacitor tries to cross the 10 volt, so what is going to happen? You are having the discharge path. Fine. And when the capacitor voltage will decrease below 5 volt, then what is going to happen, your discharge path will be open. Fine. So you will be having two limit, that is 10 volt and the 5 volt. So again this will be repetitive. Fine, this one will be repetitive, this one will be repetitive. So when the capacitor voltage is high, so I think similarly you will get the on time and the off time. This is okay. When there is no discharge path, this is 0 and this one is 1. So in that case, this is 1. When capacitor is charging, you will be having the higher pulse. When it is discharging, you will be having the low pulse. Again it is having the high pulse. Again there will be a off time pulse. So in this way you will be getting the square waveform. I think we'll try to understand the mathematical calculation of this astable multivibrator in the next lecture.